We will be looking at factoring, especially the difference of squares. Recall that when we multiplied the binomials of x plus 6, x minus 6, we got x squared plus 6x minus 6x minus 36. And when we did that, our two middle terms added up to 0x, resulting in x squared minus 36. We will be calling this the difference of squares. And why this is a difference of squares is because we can see that x squared is a square, 36 is a square, and the subtraction sign is the difference. So the idea is, do we have a sum of squares? Well, we have x squared plus 49, but is it factorable? If we look at x plus 7 times x plus 7, which would be our most likely contender, we would have x squared plus 7x plus 7x, which is actually plus 14x plus 49. So we don't often talk about factoring a sum of squares. Therefore, you really need to recognize the idea of what is a difference of squares. When factoring a difference of squares, such as x squared minus 9, we can simply recognize it as a difference of squares, knowing that that binomial would factor into x plus 3, x minus 3, or in other words, the square root of the first term, which is x, plus and minus the square root of the second term, in this case 9 square root, which is 3. If you want, you can still think of what multiplies to your constant, which is a negative 9, and adds to your middle term, right, your x term of 0x. And what adds to that would be 3x and negative 3x. The two middle terms when we take the outside and the inside of our FOIL method. Recognizing this is a difference of squares, though, saves a lot more time. So here are three problems we're going to look at. X squared minus 49. X squared minus 49, as a difference of squares, we take the square root of the first term, which is x, and the square root of the second term, which is 7. So we recognize this as x plus 7, x minus 7, and we're done. This next one, well, there's two terms, it's being subtracted, but 18 is not a square, and 2a squared is close, but not exact. So what we need to do first is look to pull out the greatest common factor, in this case, 2. When we take a 2 out, we're left with 9 minus a squared. This might not be the most traditional look of a difference of squares, but it is still a difference of squares. 9 is a square, a squared is a square. And so following our rules, we end up with 2 times 3 plus a and 3 minus a. This last one here might take us a little bit. P to the fourth. Well, 16 is definitely a square, and there's our subtraction. But p to the fourth, what we need to do is recognize p to the fourth as p squared raised to the second power, squared again. So if p squared then is the square root of p to the fourth, we would have p squared plus 4 times p squared minus 4. But we're not quite done. P squared minus 4 is also a difference of squares. So we need to factor this one more time. P squared plus 4. P squared minus 4 then factors into P plus 2, P minus 2. And so there's some of the different types of difference of squares we might see.